Alright, so hopefully you've had a chance to work out this first set of practice problems. Let me go ahead and begin working these out with you. So, first and foremost, concentration of a solution tells you how much blank the solution contains. How much solute, okay, and to be more specific, it is relative. Okay, the relative amount of the solute. Okay. Then let's see, the most common concentration scale used in chemistry is molarity. This is the one that we tend to use the most. It's more useful because it concerns the actual counted number as opposed to mass. 10 grams of table salt is dissolved in 500 mils of water. Find the number of grams per liter. So I've got 10 grams of table salt, and then I have 500 mils of water. So what we'll have to do is just convert that 500 milliliters is 0.500 liters. 10 grams divided by 0.500 liters gives us 20 grams per liter. Molarity, now I have to convert from 10 grams using the molar mass of salt, which is 58.44 grams per mole. 10 divided by 58.44, and we get 0.34 moles per liter here. And again, because it is moles per liter, the common way that we express that is 0.34 molar, capital M. The percent by mass now. So percent by mass, recall, we've got to take the mass of the solute in milligrams. So 10 grams converted to milligrams would be 10,000 milligrams of solute. I have to dissolve that 10,000 milligrams by my 500 mils of water, but recall 500 mils of water is 500 grams of water. Then convert this into kilograms, that'd be 0.500 grams. So 0.500 kilograms, I should say, which gives us 20,000 ppm. And I just did parts per million. I did not do percent mass. All right, sorry about that, guys. Parts per million is what I just expressed. Now I will do the percent by mass. Okay, percent by mass. Now, for percent by mass, we'll be taking the mass of the solute divided by the mass of my solution. So the solute mass is 10 grams. The solution mass is those 10 grams plus the 500 grams of water. So 10 divided by 510. And that is going to be then multiplied by 100 because it's a percentage. And when we do the math on that, we get it is a 1.96% solution. Okay, what I'd like you to do now is, again, take a second, complete the table below. I will assume that you've taken that time now, and I'm going to continue. I'm just going to fill this out as we go. So 50 grams of salts means I have a solute mass of 50 grams. The mass of the solvent, if I know solution is solute plus solvent, that's going to be 300 minus 50 is 250 grams. Solution volume we said is based upon the solvent mass for water solutions, so this will be 250 mils. Percent by mass would be 50 grams divided by 300 grams, and then multiply that by 100. So in this case, that gives us approximately a 17% solution. Next, I want to convert the mass of the solute into moles of solute. So we have to consider salt is 58.44 grams per 1 mole, which would lead us to 0.86 moles. Take those 0.86 moles, divide them by 0.250 liters. 250 mils is 0.250 liters of solution. 0.86 divided by 0.250 gives us 3.4 molar. Next, 44 grams of carbon dioxide, so 44 grams. The solvent mass is 500 grams, okay, based on being in 500 mils of H2O. So the solution mass must be 500 plus 44 gives 544 grams. The percent by mass can then be figured out by taking 44 divided by 544 multiplied by 100, and that is going to give us an 8.1%. Now we see here we want to know the solute moles. Solute moles would be 44 grams. Divide that by the molar mass of CO2. CO2's mass is about 44. So that's going to give us 1 mole. Now I need the solution volume to find molarity. So the solution volume is going to be equivalent, because it's a water-based solution, to the mass of solvent. So convert these grams into mils and we get 500 milliliters. In order to find molarity, though, we have to convert that to 0.500 liters. 1 mole divided by 0.500 liters gives you a 2.0 molar solution. Next, now this time around I haven't been given all the information. I have nitrogen monoxide in H2O. I have a mass of the solute and I have a solution volume. Well, what I can do from here is I can find, based on a solution volume, I know the solvent mass. 810 mils will give me 810 grams of the water. Now take 90 plus the 810 gives us a 900 gram solution mass. The percent by mass will be 90 divided by 900 times 100, which is going to give you exactly 10% by mass. Now I'm going to have to find moles in order to get molarity. So 90 grams. Nitrogen monoxide has a molar mass of 30 grams per mole. So I must have 3 moles here. It's 810 mils, must be in liters, so that's 0.810 liters. Take our 3 moles of solute divided by 0.810 liters of solution, and this is going to give us a 3.7 molar solution. Next, I have potassium fluoride in H2O. I know the volume of my solution, and I know the molarity of my solution. So a couple things can be found from here. First off, because I have 2 liters of solution, because it's a water-based solution, that's equivalent to 2,000 milliliters, which is equivalent to a solvent mass of 2,000 grams. What I'm going to do now is I'm going to use the molarity, and I'm going to multiply molarity times the volume in order to find the number of moles, okay? Because molarity is moles per liter. Liters times moles, or liters times molarity gives you moles. So 2.5 times 2 gives you 5 moles. So 5 moles of Kf. What I can do with this is I can convert 5 moles, and the number of moles in Kf, if we look here, we see that fluorine is about approximately 19. Potassium is 39, so 39 plus 19 gives 58. So 5 moles, and it is 58 grams in 1 mole. So 5 times 58, and that is going to give us 290 grams. So we carry that down here. There are 290 grams of my solute, Kf. Take those 290 grams, add that to the 2,000 grams of solvent to get the solution mass. That will be 2,290 grams. Now percent by mass is going to be 290 divided by 2,290 multiplied by 100. And that is going to give us a 13% mass. Now, this time around I've been given 3% H2O2, and this AQ indicates to us that this is a water-based solution. I have a solution mass, and I see it's a 3% H2O2. So right off the bat I can write that in. It's 3% by mass. And thinking this one back logically, 3% of 100 grams is going to be 3 grams of solute. So I have grams of solute now. I have the solution mass. If I take the mass of the solution and subtract away the solute, that gives me 97 grams of solvent. 97 grams of a water-based solution. So 97 grams of solvent would give me a 97 milliliter solution volume. And I'm just going to go ahead and take that to 0.097 liters. Now, in order to find the moles of solute, we've got to consider the molar mass of H2O2. So oxygen being 16 times 2 is 32, plus 2 is 34. So I'll take my 3, divide 34 grams, and this is going to give us 0.088 moles of peroxide, H2O2. Now, the last thing that I'm going to do is take the moles of peroxide, 0.088, divided by 0.097 liters, and this gives me a 0.9 molar solution. All right, now our final sample, all we know is that this is a hydrochloric acid solution, and it is aqueous, so that's water-based. It's given here that this is a 10% hydrochloric acid solution. But the problem that we face here is that we don't have any values. I don't know the mass, I don't know the volume. All I know is the percent by mass. In a situation like this, what we can do is we can assume a simple number to start with. We're going to assume a 100 gram sample. So I'm going to say that my mass of solution is 100 grams. And just like we did before where we had 3%, 10% of a 100 gram sample is going to be 10 grams of my solute mass. So from my 10 grams, I can take 100 minus the 10 to get 90 grams of the solvent, which means that I'm going to have approximately 90 milliliters since it isn't a water-based solution, or 0.090 liters. Then to find the moles of solute, I take the 10 grams, and it's hydrochloric acid. Our chlorine is 35.45, and the hydrogen is 1. So that's going to be 36.46 grams per mole. And my 10 divided by 36.46 yields me approximately 0.27 moles. So 0.27 moles, divide that by 0.090 liters, and we find that this is a 3 molar solution.